Hi, hello, welcome to Homeschool. This is your class 11 mathematics. We are in our first chapter sets and this is your exercise 1.4 seventh problem. If A is equal to set of all x such that x is a natural number. Natural numbers. What are natural numbers? All the counting numbers are called as natural numbers. That is 1, 2, 3, 4, 5, 6, so on. Where it ends, we don't know. In the given set A, set of all x such that x is a natural number set. Let us first convert this into roster form. A is equal to set of all natural numbers 1, 2, 3, 4, so on. Right? It is an infinite set. B is equal to set of all x such that x is an even natural number. Even natural numbers means 2, 4, 6, 8, so on. Where it ends? Don't know. So put so on. Right? C is equal to set of all x such that x is an odd natural number. Natural number and it is an odd natural number. That means all the odd numbers 1, 3, 5, 7, so on. Okay, let's see the last set here. D is equal to set of all x such that x is a prime number. D is equal to set of prime number. Prime number starts from 2, 3, 5, 7, so on. What are prime numbers? Prime numbers are the numbers which are divisible by 1 and itself. If any other number it is divisible, then it is not a prime number. Then what type of a number it is? Composite number. In this main, we have 6 sub-questions. Let us deal with the first one, A intersection B. Okay, let me write A set here again. 1, 2, 3, 4, so on. And B set 2, 4, 6, 8, so on. Intersection means what you remember? A intersection B is equal to set of all x such that x belongs to A and x belongs to B. The elements of the new set or x belongs to both the sets. X belongs to A and x belongs to B. Right? So that is A intersection B is equal to. See the elements here 1, 2, 3, 4. 2, 4, 6, 8. 2, 4, I think 6, 8 is also a natural number, will be there in this set. Right? So, all the elements present in B set are common in A set. So, what you can write? 2, 4, 6, 8, so on. Or simply you can say that A intersection B is equal to B set. See, all the elements of B set are common in A set. So, therefore, A intersection B is equal to B. Intersection, write only the common elements from both the sets. See the second one, A intersection C. Observe here 1, 2, 3, 4, so on. C 1, 3, 5, 7, so on. 1, 3, 5, 7, all these odd numbers are present in natural numbers. So, what you can say? A intersection C is equal to 1, 3, 5, 7, so on. This set is nothing but A intersection C is equal to C set. All the elements in C set are common in A set. Right? Therefore, A intersection C is equal to C. Third one, A intersection D. If you want, you can write again both the sets. A is equal to 1, 2, 3, 4, so on. and D is equal to 2, 3, 5, 7. What is A intersection D? 2 is present, 3 is present, 5, 7 all are there in A set. So what I can say? A intersection D is equal to all the elements of D are common in set A. So both the sets, D set elements are common. So finally what you can say? A intersection D is equal to 2, 3, 5, 7 you can say, or A intersection D is equal to D set you can write. Okay, next one. B intersection C. What is B set? 2, 4, 6, 8 so on, and C set 1, 3, 5, 7 so on. In these two sets, what are the common elements? 2 is not there, 4 is not there, 6 is not there. Observe here, B set contains all even natural numbers and C set contains all odd natural numbers. Do we get any common elements between these two sets? No. So, no means B intersection C is equal to null set. No common elements, therefore it is null set. Fifth one, B intersection D. What is a B set? B is equal to 2, 4, 6, 8 so on. D is equal to 2, 3, 5, 7 so on. B intersection D. Observe the elements. Are there any elements common? Yes, 2 is common in both the sets. And here remaining all even numbers, and here you can see all odd prime numbers. See, in prime numbers, we have only one even prime number, that is 2. Rest of all the prime numbers are odd numbers. Okay, so what is common here? B intersection D is equal to 2. Last one, C intersection D. Write the C set again. C is equal to 1, 3, 5, 7 so on, and D is equal to 2, 3, 5, 7 so on. C intersection D. C set and D set. Can you see any common elements? Yes. 3, 5, 7, 3, 5, 7. Observe here, you have 1. This 1 is not there here because 1 is neither a prime number nor a composite number. And here 2. 2 is the even prime number. So this 2 is not present in this set. So other than 1 and 2, you have 3, 5, 7, 11. These are all common elements. So what are these 3, 5, 7 and all? All are odd prime numbers. Therefore, your solution is C intersection D is equal to, instead of writing with elements, I write it in rule method, that is set of all x such that x is a odd prime number. X is what? X is a odd prime number. Odd prime numbers means other than 2, remaining all the prime numbers are odd. And here in this, other than 1, all numbers are common for C and D. Okay, therefore set of all x such that x is a odd prime number. Eighth main, which of the following pairs of sets are disjoint? We are going to observe which pair is disjoint. What do you mean by disjoint sets? There is no common elements between the two sets. Then those type of sets are called as disjoint sets. If there is a common element, then it is not a disjoint set. Okay, let's observe the first one. 1, 2, 3, 4. And X, set of X such that X is a natural number and X is greater than or equal to 4 and less than 6. Okay, let me convert this into roster form. This set is 1, 2, 3, 4 and this set is 4 is included. 4, 5 and 6 is not included, less than 6. So 4, 5, that's it. Now, among these two sets, find out the intersection. Do you have any common elements? Yes, 4 is common. So what I can say? Therefore, the two sets are not disjoint sets. We need to identify only disjoint pair. So let's move to the second problem. A, E, I, O, U and C, D, E, F. Observe here, do you have any common element? Yes, E is common. Is this a disjoint set? No, this is not a disjoint set because there is a common element between the two sets. Third one, set of all X such that X is an even integer. Even integer. Integer means it will have both positive and negative numbers, right? So, even integer plus or minus 2, plus or minus 4, plus or minus 6, these are all comes under this set. Then coming to other set of all X such that X is an odd integer. Odd integer means plus or minus 1, plus or minus 3, plus or minus 5. Do you have any common elements between these two sets? No. If you want, you can write and check it out. Set of all even integers means plus or minus 2, plus or minus 4, plus or minus 6, so on. And this set, odd integers, plus or minus 1, plus or minus 3, plus or minus 5, so on. Do you have any common elements? No, there is no common elements. Therefore, third problem is disjoint. Is disjoint pair of sets. Okay. So the remaining two are not a disjoint. So third one is a disjoint pair of sets. Ninth one. If A is equal to 3, 6, 9, 12, 15, 18, 21, B is equal to 4, 8, 12, 16, 20, C is equal to 2, 4, 6, 8, 10, 12, 14, 16, D is equal to 5, 10, 15, 20. There are 4 sets given in this problem. We are going to find these many problems, right? So in this main, we are going to find the difference of sets. Difference of sets means, okay, let us see the first one, A minus B. How can we write this? A minus B is equal to set of all X such that X belongs to A. X belongs to A and X does not belongs to B. What is A minus B? It belongs to A and it does not belongs to B set. In order to find this answer, first we observe what are the common elements. After seeing the common elements, the elements which are common in B and A, other than those elements, you write only A elements. See here, A minus B. Write only A elements and should not include any of the B elements. That means A minus B is equal to set of. Observe A and B. Is there any common element? 4, 8, 12. Yes, 12 is there. And do you have any other? No. So 12 is present in both the sets. Other than B set. Other than B set means this 12 belongs to B set, right? So other than 12, you write the remaining elements. 3, 6, 9. I'm not writing here 12. 15, 18, 21. That's all. This is only A minus B. Once again, First, observe the common elements in both the sets. So when you are reading this A minus B, you remember a word. In A, remove B set elements. In A, remove B set elements means B set any of the elements present in A set or not, we need to check. Other than that element, remaining elements of A we need to write in the answer. Okay, let's see the second one. A minus C. A minus C means other than the elements of C, we need to write the elements from A. Other than C. Okay, first observe the common elements from A and C. A 3, 6, 9, 12, 15, 18, 21 and C 2, 4, 6. Yes, 6 is there. 8, 10, 12. Yes, 14, 16. So how many elements are common from both the sets? There are 2 elements. There are 2 elements which are common in both the sets. Other than these 2 elements from A set, write in the answer. That is A minus C is equal to 3, 9, 15, 18, 21. Right? See the next one, A minus D. If you want, you can write in this way. Set of all x such that x belongs to A and x does not belongs to C. Okay? This one, A minus D. A and D set, observe carefully. 5, 10, 15, 20. Can you see any of the element here? Yes, 15 there. Other than 15 number from D set, D and A 15 is common, right? Other than this element, write the remaining elements from A. Because in A, you are removing D elements. Right? Answer is 3, 6, 9, 12, 18, 21. Fourth one, B minus A. Now see here, observe carefully. Set of all x such that x belongs to B. In B, you need to remove A now. In B, that is x belongs to B and x does not belongs to A. Now x does not belongs to A and x belongs to B. That means B and A, what are the common elements we have seen? B and A, what are the common elements? Only 12, right? Now, in B, other than 12, you need to write the remaining elements. From B, you need to write. Okay? In B, you are removing A set elements. That means 4, 8, 16, 20. Okay? So, next one. Fifth one, C minus A. That means in C set, remove A set elements. Observe A and C. Observe A and C. Is there anything common? Yes. 6 is common and still 12 is common. And is there anything? Only 2 elements are common in both. Now what we are going to do? In C set, remove A set elements. That means other than these 2, write the remaining elements from C. 2, 4, 8, 10, 14, 16. That's it. Now D minus A. Observe carefully. In D set, remove A set elements. In D and A, what are the common elements? Observe 3, 6, 9, 12, 15, 18, 21, 5, 10, 15, 20. So 15 is common in D and A. Now what are the elements we need to write? In D set, remove A elements. A elements, what you have here? Only 15. So other than 15, write here 5, 10, 20. That's it. Okay. Now next one. B minus C. B and C. In B, first one you should give preference. In B, remove C set elements. That means, what are the common elements? 4, from B and C. Observe here, B and C, what are the common elements? 4, 8, 12, 16. So, other than these elements, write remaining elements from B. That means only 20. Right? B minus D. Now, observe B and D set. B and D set. 4, 8, 12, 16, 20, 5, 10, 15, 20. In B, what is the common element present from B and D? It is 20. So, other than 20, write the remaining elements. 4, 8, 12, 16. That's it. Ninth one, C minus B. Observe the word here. In C set, remove B set elements. First observe what are common. 4 is common, 8 is common, 12, 16 is common. In C set, remove B set elements. If you remove, what are the elements present in C? 2, 6, 10, 14. That's it. That is only our answer. Same manner, D minus B. D minus B. In D and B, what are common elements here? Only 20. So, you need to write B elements or D elements? We need to write only D elements other than B. D minus B. In D, remove B set elements. That is 5, 10, 15. Okay. 11th one, C minus D. C set and D set. What are the common elements? Observe. C is there first. Okay. In C, you need to remove D elements. Right. Now, let me go for C set, which are common here. 10 is common. That's it. Only 10 is common from C and D. So, other than 10, write the elements of C. That is 2, 4, 6, 8, 12, 14, 16. Okay. Next, last one in this. D minus C. In D, remove C set elements. So, what are the common elements? 10 is only common. In before problem, what we have done? C and D, 10 is common. Right? Other than 10, remaining elements from C we have written here. Because C minus D there. Now, other than same 10, but write the remaining elements from D. That is 5, 15, 20. Okay. So, difference of sets is very simple. When you keep the first letter in your mind, first letter whatever you have, that set you remove the other set elements. Okay. Common elements observe. Other than the common element from the first set, you need to write the remaining elements. Okay. See the 10th problem. If x is equal to a, b, c, d and y is equal to f, b, d, g, find. There are 3 sub-questions. Let us see the first one. X minus y, difference of sets. What is the word you need to remember? In first set, remove elements of next set. That is, in x and y, what are the common elements? B and D are common in both the sets. In X set, remove these 2 elements and write the remaining elements from this. That is A, C. Okay. Now next one, Y minus X. In Y, remove X set common elements. That means X and Y, what are common elements? B, D. Now, Y minus X. In Y set, other than the elements of X set, remaining elements you need to write. That is, other than BD, F, G. right? Third one, x intersection y. X intersection y. Write only the common elements from both the sets. What are the common elements? B, D are the common elements. Okay. 11th problem. If R is a set of real numbers. What do you mean by real numbers? Real numbers is a combination of rational numbers and irrational numbers. Okay. Next. And Q is a set of rational numbers. Understand here, real numbers contains rational and irrational numbers. One more set is Q is a set of rational numbers. Then R minus Q. Okay, let us write here R, Q. R indicates real numbers. In real numbers, we get rational and irrational number. Both rational and irrational will be there. And whereas in this set, only rational numbers. Only rational numbers. Now, what is R minus Q? R minus Q means in these two sets, what are the common elements here? Rational numbers. Rational numbers are common in both the sets. So, other than rational numbers, what you have? Irrational number. So, how do we write this one? R minus Q is equal to set of irrational other than the common elements. Write the remaining elements from R. R means in real numbers. So that is set of irrational numbers. Okay. 12th main. This is the last main. Find whether they are true or false and justify your answer. Observe the first problem. 2, 3, 4, 5 and another set 3, 6 are disjoint sets. Are disjoint sets said? Disjoint means what? There is no common element. Observe the two sets. Do you have any common element? Yes, 3 is common. Then how can I say it is a disjoint set? So it is false. It is not a disjoint set. Next one. A, E, I, O, U, first set. And second set is A, B, C, D. A is common. A is common and only A is common. So if there is a common element from both the sets, can you say it as a disjoint? No, it is not a disjoint set. So for this also, false. Okay. Third one, 2, 6, 10, 14 and 3, 7, 11, 15 are disjoint sets. Okay, let us check it out. Check, is there any common element? Yes, there is no common element. No common element means they are disjoint sets. How does these look like in Venn diagram? Like this, children. There is no common element. So, first set I'll write 2, 6, 10, 14 and second set 3, 7, 11, 15. Because there is no common element, therefore the two sets are disjoint. So, what you can say it is? True. Yes, they are disjoint sets. Last one. 2, 6, 10 and 3, 7, 11. Observe these two sets. Do you have any common element? There is no common element. If there is no common element, that means these two sets are disjoint. Yes, this is also true. They are disjoint sets. Okay. With this, we are going to complete our exercise 1.4. In our next session, we are going to continue with the next exercise. Until then, keep watching. Thank you all.